In this lecture, I'm going to discuss about the three important topics. That is the Fourier transform for periodic signals, right? So we got the questions from this Fourier transform for periodic signals maybe 2 times in GATE exam. And next we have to discuss about the LTI systems, that is linear time invariant systems, how to find the frequency response or how to find the output response when any input response is given. Similarly, the systems characterized by linear constant coefficient difference equation. So in the continuous time Fourier transform, we discussed the differential equations. Now we will find the difference equations to characterize the system, right? So that these three things we need to discuss in this lecture. But before that, so we have to discuss one problem. This question I did in the previous lecture, but I have taken in the period is wrong actually. So I will do one more time, because to solve this type of questions and it's very important, so we should know. So that's why I'll do again. So just see how to do it and how to find the answer, right? So depending on the n values, etc. So first we'll find the inverse Fourier transform. So the Fourier transform is given. Now we need to find the inverse Fourier transform. And this x of e power j omega, we said it's always in periodic. So he given 0 to pi one value, minus pi to 0 another value. First we will try to draw the waveform of this x of e power j omega. So this is x of e power j omega. If you see minus pi to 0, the value is minus 2j. So this is minus 2j and this is minus pi to 0. Then 0 to pi, it is 2j. So opposite. So this is pi. This is 2j. Now, so it always periodic in nature. So we'll get what? So again, it will be repeated something like this, and so on. Here also it will be repeated like this. But to find the inverse Fourier transform, we need to do the integration up to single period. So whatever the periodic is given, that is minus pi to pi, will integrate, right? Now first we will write the formula. That is x of n is equal to 1 by 2 pi integration over 1 period x of e power j omega into e power j omega n d omega. Now over 1 period means, so the values are given minus pi to pi. So but this integration will be splitted, because minus pi to 0 one value, 0 to pi another value. So 1 by 2 pi minus pi to 0, and it is minus 2j into e power j omega n d omega, plus integration 0 to pi. Actually what I did in the previous lecture, so I have taken 2 pi here, but it should be minus pi to pi and the period is 2 pi. So a mistake, I have seen this value and I substituted directly here 2 pi, right? So that is a mistake. So generally we go like this only. Somewhere we see in the question, so that value we directly take. So that's why we should be very cautious when you are in GATE exam. That's why we have to do more practice. When you do more practice, so the percentage of errors will be small, or very less we will get, right? Now 0 to pi and the value is 2j e power j omega n d omega. In both integrations, 2j will be common. So if I take 2j out, so 2 will be cancelled. So I am directly taking j by pi by cancelling 2, right? And it is minus e power integration of e power x means e power x, that is e power j omega n by. So once we assume this is x, we have to differentiate in the denominator, that it will become j n omega n with respect to omega, so it will become j. So what are the limits? Minus pi to 0 plus, so e power x means again e power j omega n by, we will get j n only, and it is limits are 0 to, right? So now it's very easy. So j by pi will be same. When I substitute 0 here, I will get 1. When we substitute minus pi, minus of e power minus j n pi. Similarly pi means j n pi minus e power 0 means 1. So if I simplify like this, what we will get? j by pi, and here minus will be there. So first we need to substitute minus to 0. That means 1 minus e power minus j n pi by jn plus, first we need to substitute pi, so it will become e power jn pi minus 1 by jn. E power 0 means 1, right? So okay, we can take jn common, so j by pi, and it will be jn. So if I substitute, multiply with minus, we'll get minus 1 plus e power minus jn pi plus e power jn pi minus 1. So we'll get jj will be cancelled, so 1 by n pi, this will become minus 2 plus e power minus jn pi plus e power jn pi. This is the x of n. Now we can stop up to here, but this is one solution. But in the, suppose in the exam the options are given, but in that those options this value is not there. So in that case, how to simplify? So we know e power j theta means cos theta, that is cos n pi plus j sin n pi. Now n is a variable. For n value, what is the values we have to see? If n is equal to 1, it will become cos pi plus j sin pi. So all possible of n, this sin pi, sin 2 pi, sin 3 pi, it will always will be 0. But cos n pi means if n is equal to 1, cos pi, that will become minus 1. If n is equal to 2, it will become cos 2 pi. That means it will be positive, and so on. So that means this e power j n pi, we can write minus 1 power n for all possible of n, right? Similarly, e power minus j n pi can be written as cos n pi minus j sin n pi. So anyway it will be 0, so again it will be minus 1 whole power n. Now if you see e power minus j n pi, e power j n pi, we can replace by minus 1 whole power n, minus 1 whole power n. So the resultant I will write here, x of n is equal to 1 by n pi minus 2 plus minus 1 whole power n minus 1 whole power n, right? So it will be simply added. So what is the answer? We'll get one more answer, that is 1 by n pi minus 2 plus 2 into minus 1 whole power n. This is one more solution. Suppose it is not also there. Suppose now we can substitute for, suppose n even. So for n even, minus 1 whole power square, 4, and so on. So what is this value will become? Minus 2 plus 2 will become 0 for n even. This is also maybe one solution. Similarly for n odd. So n odd means what is x of n? 1 by n pi. So n odd minus 2 plus 2 into minus 1 power odd value means we will get minus. So minus 2 will get minus 4 by n pi, where n is odd. Right? You may ask why you did not put the n value here, right? So for odd, all values of odd, it will be minus only, right? Then if I want to find for n is equal to 1, so it will become minus 4 by pi. N is equal to 3, minus 4 by 3 pi, etc. But this second term will always be minus 2. So this is one way of the solution, right? So this is about this problem, right? So this is the, so in the given solutions or options, so whatever the value is there, depending on that we can, right? So substitute odd values, even values, etc. We may get one answer. We will discuss the Fourier transform for periodic signals, right? So this is similar to the continuous time Fourier transform, right? So there is a only minor change, that is, so we need to discuss first one is for constant a, what is the Fourier transform we have seen in the previous lectures, that is 2 pi a into sigma sum k is equal to minus infinity to infinity delta of omega minus 2 pi k. Reason is, actually if we compare with continuous time Fourier transform, if I recall, this a is simply 2 pi a del omega, because continuous time Fourier transform is aperiodic in nature, right? But the discrete time Fourier transform is periodic in nature, so that's why del omega minus 2 pi k. So what is the period? Here is 2 pi. So that is the change. Now in place of a, if I substitute 1, the Fourier transform will become simply 2 pi sigma k is equal to minus infinity to infinity delta omega minus 2 pi k. This variable can be any value, L, M, etc. Now if I substitute, suppose if I consider some x of n is equal to e power j omega naught n. So it's a periodic signal. It's a periodic signal with a fundamental frequency. What is the fundamental frequency? Omega naught. Right? This is the fundamental frequency. If I need time period, so it will be n is equal to 2 pi by omega naught. Now, so we will find the Fourier transform for this periodic signal. That is, so by using the frequency shifting property we have to use. That is, if 1 is there, it is 2 pi sigma k is equal to minus infinity to infinity delta omega minus 2 pi k. If I multiply with e power j omega naught n by the frequency shifting property, this will become simply k is equal to minus infinity to infinity delta omega minus omega naught minus 2 pi k. So this is the Fourier transform for this periodic signal. Now if we consider this x of n is equal to the Fourier series representation for this periodic signal, sigma k is equal to the over one period, and here the Fourier series coefficient ak into e power jk omega naught n. Right? So this is what this e power j omega naught can be represented by. It's a harmonically related complex exponentials. This is also a periodic signal. Now how to find the Fourier transform of this type of signals? So it's very easy, right? So we know, just we have seen the frequency shifting property. So just we will apply that frequency shifting property. So what is that? Using the Fourier transform shifting property, this x of e power j omega will become, see right here, using frequency shifting property, right? So what is this Fourier transform will become? Simply sigma, see here, so this will become now k is equal to minus infinity to infinity, and say 2 pi should be there, so you can write here or here also 2 pi into ak, whatever here, ak into delta omega minus, this will become simply k times omega naught, right? So whatever the frequency shifting that is, here it should be omega naught, then we will get omega minus omega naught, but it is now k times of omega naught, so k times of omega naught. But what is omega naught? Omega naught is equal to 2 pi by n. So this is a periodic signal, so this can be represented k is equal to minus infinity to infinity 2 pi into ak delta omega minus 2 pi by n into k. This is also we can write Fourier transform, right? So see, this is a periodic signal which is from minus infinity to infinity, but this x of n can be represented by only over single period. That means the Fourier coefficients ak, so it's a periodic in nature. So how to find ak? So the same formula what we used in the discrete time Fourier series, 1 by n sigma n is for one period and x of n e power minus j n omega naught k, right? So that is how to find this one. This is sigma. Okay, I'll write here sigma n is for one period, x of n e power minus j n k omega naught or j n omega naught k. So this is how to find this Fourier series coefficients. Then once we know the Fourier series coefficients, simply we can write as like this: 2 pi ak del omega minus 2 pi by n into k. So what is the n value is given, depending on that this equation will come, right? Now we will solve this problem. So x of n is given something like this, which is a periodic signal. Now we need to find the Fourier transform of this signal. Now we know that the Fourier transform of any periodic signal can be represented by x of e power j omega is equal to 2 pi sigma k is equal to minus infinity to infinity ak del of omega minus 2 pi by n into k or omega naught k. Now, so anyway, n is periodic, this function period, so n will be like this only. First we need to find ak. To find ak, first we will draw the x of n signal. Now for x of n, so k is equal to minus infinity to infinity. If I substitute k equal to 0, so delta n, right? Delta n minus n. so maybe some values will be there, but we don't require that one, 0 to n and so on. Similarly here some value minus n and so on, right? Now what we need, we have to summation for over one period, right? So if I consider only this period, so it will be very easy. So to find AK, so over one period, that is 1 by n summation of over one period. So that one period I can assume as somewhere here, right? So that is over one period, that is n is over one period. And what is here, we will get x of n simply delta n into e power minus jn omega naught k. Now what is n minus n naught? So we know the impulse function property. If there is delta n minus n naught into x of n, so the resultant will be x of n naught. Anyway, n naught is here 0, so e power j0 will be 1. So what is ak will be simply 1 by n, right? So by this equation, so we can write directly x of e power j omega is equal to 2 pi by capital N into sigma k is equal to minus infinity to infinity delta omega minus 2 pi by n into k, right? So this is about. Sometimes we can write directly omega naught is equal to 2 pi by n here also. So once we know omega naught is equal to 2 pi by n, so we can write whatever the question asks, right? In the question how we mention the answer. Depending on that, we can either simply put omega naught or 2 pi by n, right? I think this question, either it is in a continuous time Fourier transform or discrete time. So this question came in the previous gate, right? I don't remember what is the in which year, but this type of questions came in the previous gate, right? Just remember that one. Next we will discuss this LTI systems, that is linear time invariant system. That is, suppose if we are having some LTI system which is linear time invariant system, and if I give some input signal x of n, so it will produce y of n, the output response, depending on the what is the system response, depending on the system response. So generally we can say it is a h of n or simply impulse response, right? So depending on this response, we'll get the output response. So how to represent in equation form? The y of n, the output response, is equal to the convolution between input as well as the system response h of n. Now if I know x of n and h of n, by doing the convolution, so we can find the y of n, but it's a lengthy procedure, right? So if x of n is some more complex, so it is difficult to find the output response. That's why I will take the help of the Fourier transform. Now we know that the convolution time domain will leads to multiplication in the frequency domain. That will becomes like this: e power j omega is equal to x of e power j omega into h of e power j omega. All will be capitals. Now how to find the frequency response of the system? So what is the frequency response of the system? Is nothing but h of e power j omega, which is equal to the output response, Fourier transform of output by Fourier transform of the input. So this is generally we can represent as frequency response of the system, right? System means always either it is impulse response in h of n, and in frequency one, generally we say frequency response of the system. If I know the output of Fourier transform and input Fourier transform, we can find the frequency response of the system, right? And we can easily find if y of e power j omega or y of n is given, x of n is given, then we can find the impulse response. Or any two parameters or two functions are given, so y of n, x of n is given, we can find h of n. H of n, x of n is given, we can find y of n. Y of n, h of n is given, we can find x of n by using this property, right? Next one, we have to see the interconnection of LTI systems. Sometimes we make a question from this also. That is, interconnection means the first one is cascade connection. Cascade connection of two systems or maybe three systems, etc. So cascade is nothing but one after another. So one system is there, which is having the impulse response of h1 of n, and in cascade one more system is there which is having h2 of n, and here we have to get the y of n. So this is x of n is there. Now, how to find the total impulse response or total frequency response? Whenever there is a cascade in nature, the total impulse response is nothing but the convolution between these two signals, h1 of n convolved with h2 of n, right? Then once we know the total response of this system, then we can find again y of n and x of n, that is convolution between x of n and h of n is nothing but y of n, right? Again we can write y of n is equal to x of n convolved with h of n. But what is h of n? So x of n is convolved with h1 of n convolved with h2 of n, right? So this is actual. So but first we'll find the h of n by convolution these two, then we can find the y of n. The next one is parallel connection. Parallel connection of, generally we assume two systems, it may be more than two also, no problem. So parallel connection means, so this is some x of n, and parallelly two systems will be there. There is system 1 h1 of n, and there is a summation, this is h2 of n, and it is going to this summation, and both are positive only, then it will become y of n. Whenever two systems are parallel, the total response h of n is equal to the summation of these two, h1 of n plus h2 of n, right? Then we can find again h of n by the Fourier transform. We have to add these two only, then we can find the y of n by convolving with h of n with x of n, right? I'm not writing that again. Or suppose y of n is equal to x of n convolved with h of n. What is h of n? Summation of these two, so that will become x of n convolved with h1 of n plus x of n convolved with h2 of n. But we will never do like this. We do when what we consider is the Fourier transform of the systems, then we can easily find the total frequency response. Then from that frequency response we can find the either input or output response depending on the question. Next we will discuss the systems which are characterized by linear constant coefficient difference equations. Now in continuous time Fourier transform we have seen differential equation, that is some d square y of t by dt square plus 2 dy by dt plus y of t is equal to some x of t minus 1, etc. So in continuous time we say it's a differential equations. In DTFT we say it is a difference equations. So how to represent difference equations? First I will write the generalized form, that is sigma some k is equal to 0 to n and some coefficients which are linear constant coefficients ak into this one is y of n minus k. See difference, right? So it may be n minus 1, n minus 2, n minus 3. Now what is the difference is, if it is a d square we will get k is equal to 2 here. So second difference equation, that is yn minus 2, 1 means yn minus 1 and so on, is equal to sigma some different k is equal to m, right, into different coefficient or a constant, that is bk into x of n minus k. So this is the generalized equation, the difference equations, right? So this is about this one. Now how to find the frequency response from this? Now to find the frequency response we have to convert into the Fourier transform both signals. Now we know whenever there is shifting, so what we will get, e power minus j that omega into that n naught. So that is how to find the Fourier transform. See, sigma k is equal to 0 to n, the constants will be same as it is, into this n minus k, right? So n minus k means what we will get, e power minus j omega into n naught, so that is k into y of e power j omega. Similarly in this the input side, that is it will become k is equal to 0 to m, this is bk, and again it is shifting property, so what we will get, e power minus j omega k into x of e power j omega. Just now we have seen what is the frequency response, which is nothing but the frequency response of the system is h of e power j omega, which is nothing but y of e power j omega by x of e power j omega. Now if you see clearly, this y of e power j omega and x of e power j omega constant, right? So if I take this x of e power j omega like this, and this total term is going like this, so what we'll get? So we'll get the frequency response of the system is equal to h of e power j omega, which is nothing but y of e power j omega by x of e power j omega is equal to sigma k is equal to 0 to m bk into e power minus j omega k by sigma k is equal to 0 to n ak e power minus j omega k. Now we may think e power j minus j omega k and e power minus j omega k we can cancel. No, this is the inside of the summation. This is also inside of the summation, and this k is varying from 0 to n. This k is also varying from 0 to m, so we cannot cancel. This is the frequency response of the system. That is, if we know the constants of this input, that will come in the numerator, and the constants for the output, I mean the y of e power j omega output, will come in the denominator, right? Now how? We'll see a simple example. Suppose some question is given like this: some a into y of n minus 1 plus y of n is equal to x of n, right? So it's a difference equation, but first difference equation, because the highest is n minus 1. Now how to find this one? We know by the shifting property it will become e power minus j omega, because n naught is 1, into y of e power j omega plus y of n is simply represent y of e power j omega is equal to x of e power j omega. So what we need? So y of e power j omega, if I take common, this will become 1 plus a into e power minus j omega is equal to x of e power j omega. Now what will this? Y of e power j omega by x of e power j omega is nothing but 1 by 1 plus e power minus j omega, which is nothing but h of e power j omega, right? So this is the frequency response of the system. Similarly, second order or third order, etc., that we'll see anyway in the when we do problems, right? So this is about these concepts. In the next lecture, we'll solve the problems on either these LTI systems or periodic signals Fourier transform, or maybe depending on the DTFT properties also, that we'll see in the next lecture.